So plan is that aerosols and chemistry are going to go first. Since Peter Cox is indisposed this morning, and we'll just have the carbon cycle and vegetation go after lunch. And we may have a little bit of time, either this afternoon or during the day tomorrow. And we're thinking that maybe after listening to what's gone on so far, some of you may feel the urge to present a result or add something in terms of like a very short, like a 10-minute kind of talk. And so if you're interested in doing that, I'm going to pass around this sign-up sheet, and we'll probably have some time this afternoon after the carbon cycle presentation for a few, and we have time for a few tomorrow. So if you think you really would like to present something to the group that you think is relevant, you can sign up on this sheet. So I'll just pass that around. And I guess Phil Rash had a conference call that he said was going to be 5 to 20 minutes. There he is now. Good timing. So we'll let you guys take it away then.
Yeah, so you already probably said it, but Olivier's going to give a presentation. But we give credit to everybody here.
Yeah, feel free to interrupt me if there is anything missing in that presentation. We had interesting discussions yesterday and this morning, and the first thing we asked ourselves what are the reasons for having aerosols and chemistry in AR5 type of simulations that would go from pre-industrial to 2100. And first of all, aerosols are important for the historical period. If you want to reproduce the change in surface temperature, you'd better have aerosols. That helps quite a bit, especially on the regional scale, and that by itself is a reason to have aerosols. And you need direct effect and some representation of the indirect effect, bearing in mind that the indirect effect is still very uncertain. The magnitude is very uncertain. To some extent, this is true for the ozone forcing as well. It's small in a global sense, but it can be important regionally. So ozone might be an useful forcing to have for the historical period. Then there is a question of how much complexity you want to put, but if you want to have a reasonable treatment of aerosols, you need some chemistry, sulfur chemistry, and you may need some oxidants on VOCs for secondary organic aerosol. So there is a question of how you do that. But that is an argument for having aerosol and chemistry together. We've looked at the different feedbacks that would involve aerosols and chemistry in a nerve system model, and we could think of a number of them. First of all, temperature change would change the emission of isoprene from the biosphere, and then that can affect ozone, which is a greenhouse gas, so that sort of feedback on the temperature. In the same way, temperature change could affect monoterpene emissions from trees and vegetation, and that can form further secondary organic aerosols, and that's likely to be a negative feedback because that would cool the system. Climate change may affect DMS production in the ocean and flux of DMS to the atmosphere on sulfate, on CCN, on cloud albedo. So you've got potentially a feedback loop here, which has been, it's been in the air for many years now, and we're still unsure about the sign of that feedback. Climate change may also change lightning frequency, fires, emission of methane from wetlands. So there can be feedbacks on the ozone, methane, which are both greenhouse gases, on biomass burning aerosols. Another feedback you can think about is if the vegetation cover changes, then dust emission may change. However, all the offline studies which have been done so far, considering all these feedbacks, there isn't any of this feedback that is very strong. There is nothing like the potential of the carbon climate feedback to our knowledge. Yes?
This is mainly thinking about feedbacks on surface air temperature. And in the vertical profile of the temperature could be strongly affected by chemistry. Ozone, for example.
Ozone, absorbing aerosols as well. Yeah, that's true. What I'm not sure about is, some of these feedbacks are positive, some of these feedbacks are negative. However, I've got the feeling that there are more positive feedbacks than negative feedbacks. So even each of them may be small, if you add them up, it may come to something larger. But I don't think we know enough to take this for granted. If you just go beyond climate feedbacks and the physical climate point of view, you may argue that aerosols and chemistry are important for impact assessments in terms of air quality, with potential impact of human health on crops, and that's something you need to look at in an IPCC context. If you just look beyond working group 1, but you want to provide information for working group 2, and you need to do that as a rather high temporal resolution, because it's, in terms of air quality, it's important to look at meteorology and chemistry in a coupled way. You can't just do that separately. There are also potential impacts on ozone deposition and nitrogen deposition on the carbon cycle. For instance, we've shown that ozone would have a detrimental impact on carbon storage in the biosphere, and we've made experiments where we're talking about something like 70 gigaton of carbon by 2100. So it's not negligible. It comes to about the same effect as the direct ozone forcing. Interactive stratospheric ozone, I'm not sure it's quite on the agenda for AR5, but that would certainly help on it in terms of the model setup, because it's quite complicated to prescribe stratospheric ozone in an experiment where the height of the tropopause is increasing. And there will also be some interesting results to look at in terms of stratospheric ozone recovery. I've mentioned that we need to provide some useful information for working group 2, and the same is true with working group 3. They expect us to feedback some information with respect to air quality and land use, to make sure that there is consistency with the assumptions that have been made during the process of developing the emission scenarios. So that's something we need to bear in mind as well. In terms of capability, what is available now, it's fair to say that the capability exists. We've got a full range of aerosol and chemistry model. Computing cost may be an issue for some of these models, and there were also some recognition that the driving inputs may be insufficiently known in some cases to run the most complex version of the aerosol and chemistry models. For instance, if you want to run a full aerosol model which represent the aerosol size distribution, you need some information on aerosol number emissions, and we don't really have that information at the moment. And the same thing, you want the split between the different VOCs emission, and that's not very well known. All these models have been validated to some extent. There have been a number of intercomparison projects, IROCOM for the aerosol models, CCM-VAL for the stratospheric chemistry. There is a new initiative between SPARC and IGAC for tropospheric chemistry, with a meeting next week. Is that right, Phil? And in Europe, there is the Accent network as well. Probably, the full complexity of the model that we have now may not be required for IPCC simulation. Actually, we should make a distinction between the information that you want to provide for instance, the radiative forcing chapter in IPCC, where you're going to use the best model you have, sort of estimate what the radiative forcing is in present day, and the climate projection chapter, where you may not want to go for the full complexity of your model. And I think we've had some, it took us some time to realize that we were not always talking about the same thing in the group here. Because this full complexity may not be required, there are simplified approaches which are under investigation. For instance, a bulk aerosol model versus a full model approach, or a simplified gas phase chemistry that is quick enough to run but still accurate for the purpose of climate feedbacks. And also the way the coupling is done may be looked at. There might be some more efficient way, but it's not something easy. So. There was a recognition that we need common diagnostics and intercomparison studies that would inform what's going to be included in IPCC in terms of radiative forcing. if there is a wide variety of models, it may be difficult to interpret. However, I sort of feel that in the end, what should be included in the climate projection experiments has to be decided on a group-by-group basis. And what you mostly want to consider is the robustness of the scheme, because you're going to run long integration, so you're going to make sure that the scheme is robust enough, and the CPU cost, of course. We've tried to answer the questions about the sort of model that were available on a 6 month, 3 years, and 5 years timescale, but we decided to reformulate that into 2 timescales. A timescale roughly of a year, where the models could be included in the next climate projections, and then something which would be post AR5. So in terms of aerosol, what could go into AR5, we've looked at different groups around the world, and Gilles was thinking of having sulfate, black carbon, organic carbon, dust, and sea salt, with the direct and indirect effect in a rather empirical way, and I think we're talking about a bulk model here. In terms of Hadley, it's fairly similar. Bulk, sulfate, black carbon, organic carbon, diagnostic sea salt. The dust would be prognostic and probably driven by, would be interactive with the vegetation. So it would respond to vegetation changes. If we've got bare soil somewhere, the dust production would respond to that. We think we still go for a climatology of secondary organic aerosols. There would be no feedback involving secondary organic aerosols. NCAR is a bit unsure, but it could be similar to the first 2. Also, you're sort of considering the Steve Gans latest scheme as well. And I think the Max Planck will go for M7 because it's been there for quite a few years now, so it's been largely tested. The chemistry, the cost was seen as an issue, so I think every group is sort of looking at the cost and ways to reduce the cost. At the very least, there will be some snapshot simulations which will be done at 5, 10, or 20 years interval. Although there was a feeling that the interannual variability was also fairly important to look at, so that sort of point for the need for at least one scenario run with interactive chemistry, which could also be used to input for regional models which are interested in high resolution air quality studies. And then the full scheme may have to wait for the next IPCC assessment, the AR6. There was a feeling that most models in AR5 would include some representation of the indirect effect of aerosols. Although it's probably true that the aerosol scheme, the complexity of the aerosol scheme has grown further than the complexity of the cloud scheme, so the interaction may not be easy to set up. And the aerosol scheme will be more comprehensive than in AR4, that's for sure. There's been a lot of progress made over the last 5 years.
So just before you went on, I was just curious, the Japanese groups, what they were planning on doing.
For 1 year, I think we are similar to GIS. We are not sure we include the DGVM to the system, but we already calculate sulfate, BC, OC, dust, sea salt, and we also directly we continue this.
And we have already coupled carbon cycle model and atmospheric chemistry model, tropospheric chemistry model. So within 1 year, it's possible to couple those component models concerning VOC emission and so on.
Do you assume you would run that as a standard version of the model?
No. I just suggesting it's possible for us.
So it seems like maybe the critical issues that or the variations between these major centers are in terms of whether they're going to actually make predictions about aerosol number and how it interacts with cloud drops, and whether a dynamic vegetation model will be included in the scenarios run with this aerosol package. I think those were the 2 kind of uncertainties in what will happen.
Uh,
AR5.
yeah, for us it's possible, but I don't know. It should be included as a core list for core requirements for AR5. That's not.
I think that the question you just articulated is exactly the things that we think too. We're not sure. So you're right.
So basically, all these things exist, but it's unclear what form they will go into.
Right.
I mean, it looks like there's some combination of these things could go in for aerosols in some form. Like all these groups, I guess, are talking about the same things, but it's probably no group's going to have full aerosol scheme, right?
No, MPI
Possibly
with
MPI.
M7 is what we'd call a full aerosol scheme. It won't have Peter Adams' scheme, but because I don't think any of us think we can afford it. But if that's the definition of a full scheme, then none of them will have a full scheme. But otherwise, MPI is about as advanced as it'll get, and it's pretty close to the kind of scheme that we've labeled as GON scheme. And,
So that'd be the same for the Japanese groups too, right? You probably would have something short of a full aerosol scheme.
Yeah.
So,
Our aerosol is what you call a bulk scheme,
right.
not the full.
Go for
Oh,
one.
and then if you just allow me to
Yeah, sure.
one other thing was just to note that the other place where there may be distinct differences, it seems to me, is in how we treat the secondary organic aerosols. It sounds like the Hadley Center may very strongly constrain their treatment of that, and it may be possible that the other groups do something a little more predictive in nature.
I know we were supposed to discuss experimental design in a different session, but we couldn't help talking about it. And we had some recommendation already in terms of historical and future emissions. We thought there was a need for historical emissions beyond sulfur to be assessed and intercompared. There is probably a good agreement in terms of historical sulfur emissions among the different groups, but that wasn't the case for black carbon, organic carbon, or some of the ozone precursors. The VOCs needed to be split up in between the different species. Injection heights were also important. The sectorization of emissions is needed, for instance, just that helps to prescribe the injection height in the model. Something which we want to flag as being important is that we need some consistency between historical and future emissions in terms of the emission species, in terms of how the transition is done in present day. We don't want too much of a jump between the historical and the future emissions, so that's certainly an issue. Yeah.
What do you mean when you say sectorization of emissions?
I think it's emissions by different economic sector.
Okay.
Something which is of concern, and that's probably going to be a big change between AR4 and AR5, is the history of biomass burning emissions. It seems to be almost a paradigm here, where before everybody has been assuming that biomass burning emissions have increased everywhere as a function of population. So basically, people assume that 10% of the fires are natural and the rest are anthropogenic. And we've seen in George's talk, and I've seen that also from some other people, that it may not be true, that the fraction of natural fires is probably larger than what we assume in regions like Africa, and in some regions like North America, there might have been a very large decrease in the emissions. So that's something we need to get right in time for AR5, and that's going to be a big change.
So that contributes to black carbon.
That contributes to biomass burning aerosols and ozone, and biomass burning aerosols have more or less a cooling effect when you consider the black carbon and the organic carbon together.
So they emit both.
they emit both, and the overall effect is more cooling.
So I remember, like, for the tar, people like Joyce Penner were agonizing over biomass burning, and there was always this talk about biomass burning, biomass burning. This time it was like everybody just kind of just talking about black carbon and sticking it in the models in some way, but is there now kind of a disconnect between what the biomass burning is producing and what people are putting into the models for black carbon?
Yeah, not sure you're talking about biomass burning black carbon, the fossil fuel black carbon.
Well, like biomass burning black carbon. Because if you look at, like, in our model, when you look at the distribution of where Bill Collins put the black carbon in, it is kind of in the tropics and areas where there's a lot of biomass burning. I mean, that's part of it, right?
Present day, yeah.
But I don't think there is a disconnect that way. I think that the disconnect is in what people especially in the carbon community, think the biomass burning was at pre-industrial conditions versus what we assumed on the chemistry and in those estimates.
But JF, I do think there was the disconnect in the sense that I believe for AR4, the NCAR didn't change the organic carbon emissions at all over the pre-industrial present to future, and some of those were associated with biomass, should have been associated with biomass burning. We didn't recognize that effect. So, and from my point of view, there is a lot of agonizing over what the proper characterization of the amount of these aerosols that are injected in and where they're injected is going.
But you kind of know, I mean, there's probably, you can measure this from satellites, right, where the black carbon is.
There may be some of the new satellites may be able to help on this, but in fact, most of the to do a satellite retrieval, you need to have what's called a model, and the model sort of is making guesses about what it thinks the aerosol type is in a particular region, and so it isn't completely ambiguous that you can tell where the absorbing aerosol is.
So there's still a lot of
completely unambiguous.
there's a lot of expert judgment that comes into play when you decide where the black carbon aerosols are and what their distribution is.
Yeah.
Also, that again, the thing we weren't really supposed to be talking about the scenarios, but we also mentioned that in addition to historical emissions for these other types of aerosols, it would also be nice to get future emission projections for these other types of aerosols.
Yeah, it will come later.
Okay.
Yeah, we thought that if we want to make some of the emission consistent with the rest of the model, we need also good knowledge of the land use, historical and future. So it's nice to hear that there will be emission scenarios of land use as well. In terms of getting a more or less standard set of emissions, we were sort of wondering what should be the appropriate level of guidance, and whether that should come from IPCC, if IPCC is ready to do that, or whether that should come from our community if IPCC isn't prepared to do that. And also we've got to recognize that different groups will have different requirements. Some groups will need emissions, but there will be a number of groups which will probably need concentrations, and then we need to find a way to provide concentrations to these groups for a number of species. So that's something we should start to think about. And then there is the question on how we liaise with other communities we've been involved in atmospheric chemistry, like the people from the Long Range Convention of Transport on Air Pollution. They're willing to liaise with us, but we've got to do that in an IPCC context as well. Okay, computer cost. We sort of thrown some numbers, and they were not always consistent in between the models. And the reason for that is probably that depends on how the atmospheric model itself is optimized and efficient, and the type of computer platform you're running on as well. So we came with some rough estimates of how much an aerosol scheme would cost, and it was anywhere between 30%, as far as I remember, for for the Hadley Center model to 100% for NCAR if you want to go for something a bit sophisticated. The thing is that in the Hadley Center model, the aerosol scheme has been included in the atmosphere for quite some time now, so we don't differentiate any longer the cost of the aerosol and the cost of the atmosphere. It's all part of the atmosphere now, and we only recently added the dust. Just a ballpark figure was 2 or 3% of the atmosphere every additional tracer for transport would cost 2 or 3% of the cost of the atmosphere. And then the tropospheric chemistry, there were different versions, different complexity. On the overhead was between 50% for the simple chemistry of the GIS model, up to a factor of 3 or even larger for the Hadley Center. And again, these are numbers relative to the cost of the atmosphere model. There was a question on the timescale of feedbacks. We haven't truly addressed that, but I've just put two things here. There is a range of timescales, and that can have also regional and global effect. So I think it's very there is a variety of feedbacks here on timescales. But just as an example, if you've got a strong air quality control in the next few decades, that can certainly result in quite some warming on timescale of years to decades. I mean, that's been documented in some papers already. So that's certainly something you want to account for short-term climate change. The feedbacks through vegetation may take more time to materialize, probably 50 or 100 years if you want to kill the Amazon forest and emit more dust. That's very controversial, but that's one possible strong feedback. And we come with just a few requirements. We thought it would be good if the community dealing with past emissions, and that's basically Gaia and IGAC, and the emission scenario community would come together and make sure that there isn't any discrepancy between past emission inventories and future scenario emissions. We should, we're a little bit concerned about future emission requirements. I mean, I think it's time now that we pass these requirements to the emission scenario developers, and we sort of view this as an IPCC role, and there have been this IPCC paper which has been adopted by the plenary in Mauritius, but not much have occurred since then, so that's a bit of a concern, and it would be good that something happens this year so we can start to initiate a dialogue and make sure that the requirements for the model will be satisfied. Have I missed anything from our discussion? Yeah.
So what, like, could you discuss which constituents you would need time series of from the scenario community? I mean, if you had, I don't know what you exactly need, but obviously sulfur dioxide emissions is one. But depending on the types of aerosols and things like that, is there like a list of things you could communicate to the scenario community that you need?
Yeah,
Steve came and talked to us for a bit, Smith,
Yeah.
while we were here. So yeah, we have black carbon, organic carbon. And as Olivier said, the sectorization of emissions, we were interested in, we'd like them characterized according to fossil fuel emissions versus biomass versus biofuels. That kind of thing will help us a bit.
Natural versus anthropogenic.
Yeah, the natural, if we can characterize natural versus anthropogenic, we can composite them back up, but the additional information does help us, if nothing else in the interpretive stage, even if it isn't used when we're actually sort of driving the model.
Yeah, we've discussed that a bit. We haven't formalized it to a point that we can really pass it to the emission scenario developers, but it shouldn't be too difficult.
So the question is, if you came up with a list, are there people in the scenario community that have the expertise to actually fulfill those requirements?
Not every group, I think, but people like Naki and Steve Smith seem that they can do it.
So they
But-
could probably cover the list of things you could think of.
but not every group can do it. I mean, there are hundreds of emission scenario developers in the world, and only a few of them can really address all of our requirements in terms of land use and sectorization of the emissions. And
Well, and Naki was indicating, that certain of the models that he likes to work with are completely incapable of doing a historical.
The past may be more of a problem than projections. Sometimes you have to be right to projections.
Well, the reason why we said also the sectorization of emission is needed, and what Steve Smith said also, is that if you want to have the consistency between historical and future emissions, it has to be done on the sector, not on the total emissions. And if we have the different sectors like transportation, industry, and so on, it's not that difficult to do. So, and we didn't see any big problems on that, just we have to do it.
Yeah.
And the more information we have on the sectors, and then the better we can detail the VOC emissions.
And so that's those sectors are known, and there's people that generate those numbers.
Yes, they are known. What is not totally sure is that they are the same used by the people dealing with the past emission and people dealing with the future. But I'm pretty sure, at least the people dealing with the current emissions, they have so many sectors that there is no problem. For the past emission, to have just a few sectors, are they the same as the people doing the scenarios? I'm not sure, but it should not be a big problem, you know. Transportation is one, and industry is another one, so it should not be very different, I think.
Question about the difference between sort of a scenario and a land surface model capability. In other words, would you like to have a scenario of the emissions from biomass burning, or would you like, it seems like what you really want to have is a land surface model that was able to predict this, in some sense, history of emissions, because then you'd get the carbon consequences as well, and the land surface changes as well.
yeah, ideally, you would need that. I'm not sure how many groups will be able to do that in time for year 5. I don't think our group will do that. So we will still prescribe biomass burning emissions independently from our carbon model. That's my feeling.
We also talked about, I can't remember 5 minutes ago whether you covered this or not. We also talked about if we wanted to do a model intercomparison experiment, should we be giving the models the emissions, or should we be giving them all concentrations as a function of altitude, and latitude and longitude, for example? And it could be done both ways, of course, but if it is just a constrained latitude, longitude, altitude concentration, where do we get that concentration from? And do we use one particular model's version of it, or what?
Yeah.
So to elaborate on what you just said, I'm a broken record here, but we thought it would be kind of interesting to, if modeling groups were willing to do it, and Olivier's indicated that it might be, they may not want to spend their computer resources this way, but for example, we think that it would be very interesting to look at the historical record and to identify through a model simulation what the sensitivity is to the assumptions about how the aerosols have occurred historically in replicating, let's say, the manned hockey stick time series, where you could do things like let all the models do their best possible simulations their own way of the evolution of the greenhouse gases plus the aerosols, and then prescribe the aerosols using a time series of concentrations over the whole atmosphere as a function of latitude, longitude, and altitude, to see how dependent is the ability to replicate the distribution of that, or the evolution of that time series on the aerosol distributions themselves.
Presumably you mean just tropospheric aerosols, not
That's right.
monsters.
Well, one might need also to fix the way in which you allow the solar variability to evolve in time, and the volcanic aerosols as well, in order to do this. But
The history is there is in the IPCC report now, in the Paleoclimate chapter, a graph that shows all the different model simulations from 1500 or 1000 AD to the present. And you know, they don't all look all that different from one another. But what's buried in that is they're all doing it entirely different ways. Volcanic, solar, land use, tropospheric aerosols, all the different groups did it entirely differently. But they all had in mind sort of an idea of what they wanted to get out, maybe, I don't know. In fact, one example, without mentioning any particular model, they had originally considered using Tom Crowley's volcanic aerosol distribution. But then they thought, oh no, that gives us too much cooling, so we'll cut it by a half. So they used 1/2 this volcanic aerosol. And then they got sort of this nice picture that matched everybody else's picture. So yeah, to do it the way you're suggesting would produce some eye-opening results.
This is an issue. This is going to be an issue as more groups have these Earth system type models. They're going to be generating all kinds of different things in different ways, and it's going to be almost impossible to intercompare them on a common basis. You're just going to have, you know, realizations of climate change produced in all kinds of different ways. We kind of, you know, Olivier mentioned that we ran into this just on one level initially for the sulfate aerosol concentrations this time, where some groups had sulfur cycle models that could use emissions, sulfur dioxide emissions, and each of those groups is generating their own concentrations from their own models, but then other groups were using the data set that Olivier produced. But right there you had, you know, different models doing different things, and so it's hard to make sense of, you know, if the models show different response, what's it due to? And it kind of goes to this complaints people have had about the 20th century simulations, where, you know, different groups were allowed to use whatever forcing that they felt was most appropriate, but then that adds more uncertainty because part of the model spread is due to the different model response, but part of it's due to the different forcings. And we're going to get that. It's just going to get worse and worse for the Earth system model. So it's almost like you have to have a different kind of philosophy of how you assess results from those types of models, which we probably can't anticipate yet. But I mean, this problem is going to get worse and worse. Which, I mean, worse is a relative term. You're going to have a more diverse range of results. So it'll be a different kind of way of thinking about it than what we've tried to do so far.
Jerry, isn't it really a continuum? I mean, if every model was doing everything exactly the same way, there would be no need for any comparison, or they'd be the same model. So it seems like, to me, it's just expanding. It's a continuum.
Yeah.
It's just getting wider.
Yeah, it is. Yeah. But even if you have the same forcings, the models would respond a little bit differently. And so you want to. So there's one.
But they still differ. They still have different
differences.
differences.
Yeah. So that's one way of quantifying uncertainty. Say, okay, we have an uncertainty due to different models responding differently to the same forcing. And then we have an uncertainty where different models respond differently to different forcings. And then you have an uncertainty due to the fact that all the different forcings are different. And so it just kind of, you get this kind of big, the envelope keeps getting bigger and bigger, which is maybe not a bad thing. I mean, that's just the way things go. But I think reviewers and some people look on the outside in what we do, think that that's really just ridiculous.
Yeah.
How come all the models can't use the same things? How come you can't get really consistent, uniform results? And you just can't do it. But that's just the state of the science. So it's not. I don't think it's a commentary. It's not a value judgment. It's just kind of how the science is done. So that's. I think you're noting that this is an issue, and it's been an issue in the past. It's going to be a bigger issue as we get more into these.
But you could imagine some kind of nested, model experimental design that I think maybe you're alluding to, where you make everybody use the same forcings and compare the models, then let them use different forcings and compare them again.
Yeah, and that could be that could be part of this model or the experimental design discussion.
Right.
So, and initially you're thinking, well, okay, everybody's still going to have a basic AOGCM. And so that's still going to be, probably those models will be more comparable than when you start adding your system components in. So then it may be, then you can imagine like C-format was an example of, they're trying to get at the size of the feedback from adding that particular component. Then you think, well, maybe you can do that kind of thing with almost all of these components. Each group can add in whatever, you can add in each group's version of chemistry and see how big that feedback is. And we'll spend all our time doing Wagner comparisons.
Be careful what we propose.
Yeah, right. Well, that was the thing that apparently came up in the other group, was there's all this idea of community experiments versus kind of cutting edge, interesting science experiments. And so, what we're talking about here is kind of community experiments where, and there have been complaints in the past that our community spends too much time doing community experiments, not enough time doing specific individual cutting edge, kind of expanding the envelope kind of thing. And I think it's turned out to be kind of a balance in the past, but I don't think you want to get to the point where everybody's, all you're doing is generating results for some community effort when you want to spend some fraction of your time doing interesting, and putting in unique things that no other group has. I mean, that's part of the interesting thing is you want to do something that's unique. Make a big splash result and satisfy your funding agencies and things like that. But there's also this kind of community aspect to it where coordination to a certain extent is desirable, so you can make sense of this kind of body of work that's going on. But I think you've kind of touched on all those things already in what you were talking about. So, did you guys have anything else you needed to add, or?
I think we definitely said everything we knew how to say.
Okay, good.
Maybe a question to George. You've shown the trend in fires, but you haven't estimated the emissions, that's right?
No, I have.
You have.
Yeah, I didn't show that though.
But globally or over the US?
The study that's published for the U.S., unpublished globally.
Other groups are also working on that as well. I know that the UK group is also working on global emissions and fire area, burnt area, fire intensity, and that sort of thing.
It's complicated because I think of it as there being this wildfire component
You'll do
and then this human component. And the human component, as you've noted, has a different sign in different regions and changing through time. And so it's complicated.
I think it does go back to
Okay, so I guess you guys can decide amongst yourselves kind of how you're going to write this up, generate some kind of text based on this.
Are you looking for a couple of pages?
Yeah.
And how soon does that have to be done?
Not this week, but you may think about trying to work on it this week so you don't have to do it later.
This week.
Okay. Kathy said this
While
week.
you're here, I mean,
That is safer.
if you can.
Safer if we do it this way.
Just combine all those things.
You have a lot of it already.
Yeah, you have a lot of it already up there, so you just have to fill in. Yeah.
Well, we'll work on it.
You can do a detailed outline this week.
Yeah, well, if we turn this into a Word document, it's already one page. Then all we have to do is wrap it up, and
Yeah,
there's
there
2
you go.
pages. So.
Just put in the connecting words.
Yeah.
Okay, that's great. So, is there anything else you wanted to add?
Not with respect to this, it's just what we want to do next. We want to go forward with carbon and
Well, we may want to wait for Peter to arrive here, so.
yeah.
So maybe we can just adjourn for lunch now and then reconvene.
But lunch may not be here.
Yeah, lunch isn't here, but we can adjourn and.
Yeah. Well, if lunch is scheduled to be here at 12. So what we could do is, there's, I don't know, 8 or so of you that are going to meet with me. We could have our meeting and then have lunch after the meeting. The rest, I guess, would be on your own.
Yeah.
And then we reconvene at
1:30.
1:30. So the people that want to discuss the future themes, why don't we go over there, and we'll keep our eyes peeled for when the sandwiches are.